Hey everyone, welcome. Excited to have you here and excited to be here. We've got a couple great people to talk about engineering for reliability. Um, Excited to have you, excited for you to be here and to hear all about our story. So, Yuri, why don't you start off by telling us about your framework for evaluating risk for a service before launch?
Sure thing. I should start by saying that the framework that is not actually mine. It was developed by the team that I'm a part of, which is the customer reliability engineering team here at Google, prior to me joining. But it is a framework that I have used with cloud customers, and I've seen it used to great success. Um, there's actually a couple of pieces to it. The first part is kind of the relatively straightforward pre-launch checklist that we use, which essentially is just a template, and I imagine that most of you have something similar, where it's basically just a way to ensure that you have all the information that you need prior to the launch event itself. So this is really what we use to help our customers get ready for big launches. It's things like, do you know what your primary signals of health are going to be? Do you know what your alerting is set up as? Do you have your sort of incident handling and on-call procedures in place? How are you going to know if you have problems? What are you going to do in response to those problems? Are you aware of your critical dependencies? Those kinds of things. That's a little bit different than the risk assessment framework, a template that we use. So what we're after there is this essentially idea is if we have some reliability targets set for our service, and hopefully they're expressed as service level objectives or SLOs, what we want to identify is what are the top things that could possibly threaten our SLO. Now, and that's true at launch. It's also true in the steady state environment as well. So we basically kind of approach it by enumerating essentially what can possibly go wrong, informed by prior history of our own knowledge of the system, our own knowledge of dependencies, our knowledge of the processes of how changes to the systems are made, and things like that. Then for each thing that could go wrong, we score it in two dimensions. The first one is what's the likelihood of it occurring, or how frequently do we expect it to occur over a given time period. And then the second score is essentially if it does happen, what would be the impact to our air budget or the impact to our SLO? Would this be a full outage? Will it be a degraded service? For how long would the problem continue, so we kind of know basically how much damage to our air budget we do? And then we multiply those together and we create kind of a simple list that says here are the things that we really should be focusing on as we look to approach our launch or even our steady state for our system.
Gotcha. So I think the new to me idea is, actually writing out what the risks are to a service and actually writing out and thinking through what may go wrong. Laura, do you have a kind of checklist of how you think about risk for a specific system before you launch it?
Yeah, I think I would say that it's similar to Yuri's, but it falls in sort of a slightly different philosophical perspective. The thing that I've found over time is that if we just try to make a list of everything that can go wrong, we wind up focusing a lot on specific events and specific triggers. And sometimes those are not in our power to prevent. And it can be better for a team to think instead about the separation that I like to use, and this also is not mine. This comes from research done in various systems engineering fields. But the separation that I like to use is we have our system and we have our environment. And where that line is your own engineering decision, but the system is things you control and the environment is things that you don't. And the aim is to say, given our system, what is the worst case set of environmental conditions we want to control for? And if we hit those worst case environmental conditions, is our system still okay? Are we still in a safe state in our system? And the reason that can be a better framing is because it gives you clear pictures of, or the reason that I find that can be a better framing is because that gives you a clear picture of what do you do then, right? And it's not prevent somebody from DDoSing us, right? If the risk we're concerned about is somebody will DDoS us. You no longer need to say, well, how do we stop people from DDoSing us? You say, well, what is our worst case response? What is the worst case DDoS we're worried about? And how does our system respond to that? What kinds of conditions, what kinds of headroom, load shedding, et cetera, would allow us to respond to kind of the worst instance of that we're worried about. So it gives you I find that it gives you a better picture of what you would want to do to prevent the actual risk from manifesting.
Gotcha. Interesting. So already we have two kind of potentially conflicting, but really, I think if you take both perspectives, could potentially be useful together. Got it. And then we've talked about risk. Is there a connection between risk and errors? There's this idea of a service functioning, and we all know in our day-to-day that there's multiple degrees to which a service functions or doesn't. How do you determine those kind of things? And I'll call on Drew for that.
Sure. So, Laura was mentioning that there's a lot of classes of risks that we might identify that our systems are already going to be resilient to, right? A certain level of DDoS isn't going to matter. If we think back to much older architectures, like before we had redundant web servers, for example, it was a big deal. Oh, what if our web server goes out? Nobody cares about that nowadays, right? Because, we're running 100 of them. That doesn't matter. So the more we are sort of building know that our systems are going to respond in predictable ways to them. And then that sort of a lot helps you focus on the types of errors that you actually need to plan for, or that you need to put additional monitoring or protections in place for.
Gotcha. So I think that brings up another point that I want to bring to you, Drew, which is what should error budgets mean to an organization?
I think as much as possible, we want to try to tie them back to core customer metrics, right? There are lots of internal errors that can happen inside the system that we're generally more tolerant of if they are not impacting the customer experience. And that might be, like a revenue number, if our shopping site is out, then we're losing money, or that might just be a bad experience. There's also lots of internal things that can have cascading effects. And so one of the objective issues that you might experience and push them into non-customer impacting areas, right? That's what keeps you resilient. That's what keeps your website up. Even when you're having, a dumpster fire internally, you are still operating for your customer the way that they expect. So tying it back to customer impact is a really important part of that.
Gotcha. And speaking of customer impact, I'm sure, Raphael, you have an interesting perspective, to say the least, on how to measure customer impact. Do you mind telling me a bit about how you think about customer impact?
Yeah, of course. Well, customer impact is kind of like the point at which you're kind of losing the trust of people, right? When people are accessing your platform or depending on your platform, whatever is the product you're building, as soon as your system stops answering or stops being useful, people are migrating and going somewhere else or finding alternative solutions than what you can provide, because they kind of losing trust in you. And there is a number of layers you can have in trust, and your platform being down or not being accurate and not being reliable in something that we can say we can depend on it and we're going to be able to work on it, is something that's going to impact your work in the end. And at Shopify, the kind of platform we have serving merchants, allowing them to kind of get money at the end of the day and sell their product. If we were working only a day over 2 days, that wouldn't be sufficient. We need to be up most of the time to actually be able to serve them and to provide them the service they're paying for, they're trying to use, and be able to kind of get their money at the end of the day and get the service they want to provide to their customers.
Gotcha. You mentioned something we haven't really talked about yet, which was accuracy. I'm sure in your case, having accurate data is one of the most critical laws, right? Like for designing a system. I'm curious, do you have any frameworks for thinking about risks for data specifically, or is that kind of a separate and architecture specific thing?
In terms of data, I know we're kind of having monitoring pretty much all over the place to know what's happening. We want to understand what's happening in their system in terms of the architecture itself, the infrastructure, communications, everything that's happening in the network, because as everyone says, it's always DNS. The reality is actually it's always the network because it's always linked to the network in some way. And we need to have accurate data. Like we need to know what's happening for the customers. We need to know what's happening for the merchant. We need to know what's happening for everyone connecting to the platform. And we're grabbing that from a different number of ways. We have actual data coming from like synthetics tests that are giving us the information about what's pretty much happening, but it's not necessarily always accurate on a user point of view, because it's not reaching the customer. It's not what experience the customer would have. So we also are using a number of real user monitoring data that are embedded in some of our pages to actually see what's happening for the people connecting to the platform. What are the delays they're experiencing? What are the efficiency they have for the platform? And then all of those monitoring coming together and the number of connections we get, that kind of information also allows us to identify when there is like a drop in traffic or something happening that might require us to actually understand what's happening.
Gotcha. So as much as you can getting a better picture of the ongoing status of your systems and trying to get as much specific and useful information for the state of your systems in general on an ongoing
And I think
basis.
especially the actual customer experience, wherever you can get it. So for something like Shopify, like what is the rate of filling up a cart and then successfully checking out, and has that changed, right?
Yeah.
So it seems, Laura, like you have a bit to say here about maybe how to measure what seems important or measure what is critical to your system. Do you want to talk a bit more
Well,
about that?
I think we're all on the same page that what's critical is, can your customers use the system, right? Does the system do the things that your customers need? And SLOs and our internal metrics are, generally speaking, proxies for that. And when you can directly measure, does it work for the customer? That's better, right? If you can measure, does my customer successfully log in? Does my customer successfully load the dashboard page? Does my customer successfully do a Google search? Whatever, right? To the extent that you can measure that direct impact, did the user accomplish the thing the user meant to accomplish? That gives you much better data about whether your system is working than, did I serve 500s? Like, that's not good, and it's a proxy for my customer can't accomplish something, but it's not the same as saying my customer can't accomplish something. Like, at the end of the day, we're here to make it so that people can do something with computers, not to prevent the computers from giving out 500s.
Gotcha. So it seems like
I do
going
want
up.
to say,
Go.
sorry, Kirk, I just wanted to add one more thing to kind of build on what Laura is saying. This idea of having your measurement of reliability be as close to the user as possible. I absolutely agree with that, and obviously that's the best place to do it. But I think for folks that don't have any good measures of reliability today, that maybe are still operating off like infrastructure metrics and things like that, and who are looking to improve their ability to measure the system, I would encourage you that, if the best you can do is like get your error rates from your server logs or something like that, that's still better than kind of saying, well, we can't really measure it at the load balancer or at the client, so we're not going to do it at all. Like, don't let
anything's better than nothing. Totally agree.
Exactly. That's exactly right. So, and I think that's a common thing that we see is what folks will say, like, right now we're just operating off, like, we get alerts if our, we have stuck high CPU or whatever. And we really want to be doing it at the client, but like client-side instrumentation is difficult, so we're not going to do it at all. Like, there's a world of things you can do between those two that will still get you to a far better place.
Yeah, and just to be honest, like in even like big companies that have the means to actually have real user monitoring, most of the time when you want to deploy new infrastructures and new change, and you're not yet at the point of deploying it to real user using that new system, you're actually using that kind of monitoring, the infrastructure monitoring, the data you can get from there to identify if there is any bottleneck, any performance issue with the thing you're developing. So that's already the first step we're using, even when we have real user monitoring accessible later on in the process.
Yeah, but as the systems get more complex and as you wind up with more, for example, like back-end systems that are 2 or 3 layers removed, something more definitely.
Seemed like you cut out there, Drew.
Oh, sorry, I just said it becomes more valuable.
Oh, yep, of course. It seems like this is a bit of a conversation, and it's something that I've seen at Datadog over the years too, is, going up the layers of abstraction, right? Like starting off with infrastructure and then getting something like distributed tracing, APM with your application, where the layer of abstraction is no longer your CPU or your hard disks. It is the services you've deployed and how they're functioning within each other. And I think evolving that system and improving it is a process, obviously, and we do what we can given whatever state we find our systems that we happen to steward at the time. Okay, so one thing we haven't touched upon yet is the idea of security, and how do you reason about security for a system, or how do you kind of manage risks for a system? I think, Laura, maybe I'll call on you to give me a bit of context about how you think about security of a new service, security of an existing service. Just like give me the context of, I know nothing about security. Where should I start?
I go get some experts. I know just enough about security to know that I am not an expert and that I should not be making these choices. But assuming that I don't have experts available, some basic things, right? Like be careful that your logs are logging the things that you expect and not the things you don't. Restrict access that users don't need. That's also useful to prevent production incidents, right? If nobody can accidentally delete the service, then you're not going to have somebody accidentally delete the service, so that can be useful. And a similar framework to what we were talking about earlier with more general production risks, right? What are the things we want to defend against, and how can we keep ourselves from being in a state where that's not safe? But my real honest answer for security is I would go get an expert.
That's fair.
I think one of the things that we look at a lot on especially when you're talking like launching new services, is a lot of the more fundamental principles around, least privilege and compartmentalization. Those, because you want to give people the ability to try something new, like launch a new service, but not have it be a danger to everything else you're running, right? So if you're compartmentalizing them properly, then those risks can be much, much lower, when they're not like running on the same network or running on the same cluster as other critical infrastructure until they become well-baked and well-reviewed. And that's what gives you a lot of that latitude. So a lot of those are like the original principles. And when you're in a rush, you can often get like, oh, well, can't we just throw it here next to this other thing and get it out the door? That's like the worst time to do that, though, right? Because those principles are hard won on why you should be doing those types of things.
Gotcha. And I do know, at least within Datadog, we have an actual team that we can reach out to, and we can, before we launch a service, we have a security team evaluate the service for that exact specific thing. We do have a team dedicated to evaluating risk for a service before it gets deployed in the wild. Yuri, do you have anything to add here when it comes to the topic of security?
Yeah, I've got a couple of things, and I think like Laura, maybe the thing zero is, you should get some help from people who actually know what they're doing. In my experience, there's, I think, 2 major things to think about. The first one is a lot of the same kind of best operational practices that lead to good reliability will also lead to good security, right? So the kinds of things that Drew has already called out, that Laura has already called out, the same things that make your system, more reliable, right? This approach of, having good logs, knowing what you're logging, separating dependencies, understanding your dependencies, using a least privilege approach to permissions. Those things make your system both more reliable because it reduces the risk of someone breaking something, but it also makes your system more secure because it reduces the risk of people getting access to data they shouldn't be. The second thing I would say is you should think about trying to make it easy for people to do the right thing, right? We often see security issues because people basically try to bypass security measures because they need to do their job and they don't have an easy way to do the thing that they need. So they find, the incorrect way that basically either creates or identifies a security breach. One simple example from like the world of desktop management, right? Give the people the software that they need because they will go and download it if you don't. And then when they do that, they will likely corrupt their machines. And like we've all seen that, right? And that's an example where if you make it easy for people to do the right thing, if you give them an easy way to get software that's been vetted and tested and is known to be secure, they're not going to go off on the internet and download all kinds of nonsense. You can do the same thing with your operational practices in your back end, right? Make it easy for people to have the access that they need so that they can do their job. I think those two things go a long way towards establishing kind of a better security environment.
And I would call out that that's also how we build a more reliable production system, again, because if you make it easy to do the reliable thing, to have retries that behave well, things along those lines, then people will do them as opposed to not.
Yeah, and to add on top of what you've been saying on the reliable aspect and the link to security, one thing, the way I see it is like everything is based on trust, once again. Like reliability is to keep trust, and I think security is the same. And it's actually even more of the same in the fact that security is kind of important because if your site is not up temporarily, that's something you can get back from, right? Like your platform was not accessible for a short amount of time or longer amount of time. It can happen. That kind of thing happens. That's the thing that happens generally in the shadows, and people are complaining because it wasn't working or anything. But then once you're back to be up, it's done, right? People are going to joke about it for a few weeks. When I talk about it, that's fine. But you didn't lose more trust than just that time being done. When you're actually having a security incident, when you're losing data that's important to customers, that's not something that you're done with once you're back online. Like you can fix the security incident, you can patch everything you want. The data is already out there. It's too late. You've lost that data, there is something that happens, and yeah, a company will get back from that also. But that trust is way longer to get back from. Like you lost trust, and you're not going to get back trust, and that's too late. The data you lost it. And I know that a bunch of companies are hosting a number of personal informations about people. At Shopify, we have credit card informations in some of our systems. Well, we have like merchant informations. We have addresses of people, customer base, and everything of different shops. And the thing is that we cannot afford to lose that information. So in that kind of situation, it's even better to actually shut down your platform if threat that's happening right now than actually losing the data leak. That would be like on the reliable aspect of your PT would be at the top for me because of that. That's not something you come back from easily.
Gotcha. So security kind of being the top of the pyramid, if you will, for the most important, most critical thing. And yeah, I think makes a lot of sense. I'm curious, we've talked a lot about reliability. We haven't really touched much upon scalability. And, I'll leave it to whoever wants to respond first, but kind of what is the difference between scalable and a reliable system? Are they the same thing? Or are they kind of different approaches to the same problem?
I can go ahead and start on that. That's for me, that's two concepts that are heavily linked, but not exactly the same. Like if you were to draw a Venn diagram, there would be definitely a big part of it that would overlap, because a number of concepts to actually reach reliability are based on scalability, based on the same aspect of what you would get to reach scalability, right? You would deploy more servers, you would deploy like different load balancers that are like moving your traffic around. Like the way you would deploy your infrastructure to actually reach reliability and the way you would deploy it to reach scalability are very, they're very linked. Now, I'm not going to say they're exactly the same because they're going to have concerns that like in that you're not in another one. For instance, if you want to make a database model, having redundancy would be could be sufficient. Not saying would be, but could be sufficient. While like making it scalable, it's not necessarily requiring the same. But at the same time, if you want to make it scalable and you're still talking about a database, then you could actually start sharding your database, which sort of makes it more reliable, right? Because if you're losing part of the information, you're not losing all of it at the same time. So of course you would use both of them if you want to reach a better situation of being reliable, but at the same time it gets you to a better position to be scalable. So I think that I'm talking database here, but that would be the same for any kind of concepts. And for me, they're very linked, exactly the same, because they have like means of doing things that are very specific to the area, that are not necessarily serving the other all the time. But most of the time, the practice we will use to actually grow our systems would be part of that overall area of the Venn diagram.
Agreeing absolutely with everything Raphael said. I have a couple of sort of things that I think are interesting about scalability, and one of them is still an overlap with reliability, which is that as we scale our systems, we often find that we've built in an unexpected bottleneck. So it's quite common to have a system that scales up to a point and then tends to fall over very abruptly as you hit some particular limit. That's sort of reliability in the sense that it stopped working, but it's not reliability in the way that we often think about it. We often think about reliability as degrading a little bit more gradually rather than very abruptly. So that can be a place where scaling can be differently behaved. Basically, you resolve that with load tests. I don't know that we've got another good solution for how do you anticipate. The other one that I think is interesting to call out in terms of scalability is cost. Do your systems scale linearly or sublinearly with cost as you get more users and more scale, or do they scale superlinearly? Because that can matter a great deal as you start to really scale. And that's really not about reliability, except in the sense of how much money are you spending.
Gotcha. So introducing a completely new topic, which is cost effectiveness of our systems. Okay. All right. Fair enough. And yeah, we've talked a lot about, ideal hypothetical environments, right? Like where we are in charge of greenfield new service. And I think very much that is not the case in reality and not the case in the systems that we inherit. I'm curious, we've talked a lot about the ideal world. How close or how far away is your immediate reality, and how do you bridge that gap when you kind of, not necessarily at your current jobs, but when you come into an existing system and you're responsible for improving the resiliency of an existing system that has been struggling? Kind of where do you go? What is your first approach to get a handle on the situation? And Yuri, I see you nodding your head as though you want to answer this.
Oh, sure. So to kind of directly answer the latter part of your question, where I always start myself and where I encourage others to start, as well as, like we're working with our customers, is to understand the objectives, to really understand what is the appropriate level of reliability for the system in question. The way you phrase the question is, what do you do if the system is struggling with the resiliency or the reliability? I think it's a question of how does that struggle manifest? Because there could be a few different things. And typically when I work with customers, it's actually in one or two dimensions. The first one is around actually improving the reliability of the system, meaning users are not sufficiently happy. We need to make our users happier by actually improving the quality of the service that we're delivering. It needs to be made faster. We need to reduce our error rate. We need to reduce the number of outages. We need to reduce the duration of our outages, right? Those kinds of things. And then, yeah, depending on like which one of these we're talking about, there could be different things that you take. The second aspect of it is kind of the other side of that coin, which is our system is actually reliable enough, like we're able to hit our targets, but we can't sustain it because of the amount of labor and toil that it takes. The expression we use is we're feeding blood to the machines, if you will. Where we have too many things that we have to do manually, it takes a lot of toil to actually keep this thing up and running. We don't have the ability to do any of our project work because we're constantly fighting fires. Everyone's overworked and burned out. We get too many alerts, all of those kinds of things. So, we're able to keep the system running the way that our users need it to run. So as far as the users are concerned, things look okay, but the team is not, this is not sustainable for the team. So that would be a case of focusing more on, revisiting our SLOs, revisiting our need for automation, revisiting our incident response and on-call practices and things like that.
Something I would call out there, and it's a little bit embedded in your answer, Yuri, but also like, why is the system this way? What problems were we solving when we wrote it this way? And how have those problems changed? Let's revisit our assumptions, which is a little bit revisiting our SLOs, but it could also be other questions about like what architectural landscape has changed, how has the expertise on the project changed over time, what new infrastructure might be available to us, just in general. What kinds of assumptions did we make when we wrote this software originally that we might now be able to readdress in order to make things better from where they are? Like, I think sort of inherent in the framing of the question is like somebody wrote this to start with. And I think it's really important to remember that that was a smart engineer who wrote something that worked, that has gotten to the point where we need to do more things to it. And that's a lot of success. And we should assume that that person made good choices. And now we can revisit some of those because the environment's changed, but not, they didn't know what they were doing. So I think that can be really important to remember.
That brings up a audience question, which is how often do you review existing risk assessments and adjust it? And kind of what is the appropriate schedule there?
I would say in practice, the answer is probably not often enough. But we generally advise customers to revisit their SLOs if they do have them at least quarterly. And certainly when you're first starting out with this idea of actually being customer focused in your reliability metrics, maybe even more often than that, right? You're going to be revisiting your SLOs and your performance against them on a bi-weekly, monthly basis, and you're kind of regularly scheduled production meetings to make sure that there's like two things that you want to continue to understand. One is, are we actually meeting our targets, which obviously is important, and that's a relatively easy thing to understand just based on your metrics. The second thing, which is a little bit harder to understand, is are our targets the right targets? Are our SLOs actually set at a place where they represent the point above which users are happy enough and below which users are not happy enough? And kind of without revisiting those, without really having some sense of, hey, like our thing, we had some degradation last week, but as far as I can tell, like users didn't seem to notice and no one cared, right? That's an indication that maybe your targets are too high. Or the opposite, like we're within SLO, but people keep complaining, right? That might mean that your SLO is too low. And initially, like I said, when you're first starting out, you want to review this pretty frequently. And as you get more into a steady state, that it stretches out over time. And the same thing should be done with your your risk prioritization as well, because that ideally the outcome of that prioritization effort is like work items in your engineering work planning. And as those things get addressed, hopefully some of those risks start to either move down the list or fall out entirely. And you need to make sure that you're continuing to reevaluate those, to continue to make sure that you're working on the things that are relevant and important to your service.
Yeah, to Yuri's point, like about. Go ahead, Laura.
No, go ahead.
Okay, I was saying to Yuri's point about not looking at them often enough. I think like often those are the best learnings. And so whenever you do go in and you look and you find something like Laura was describing, where you go, oh, somebody smart built this, but the yet in changing the way this operates to match the current environment. Like every time you go in and find one of those, that's a good signal that like more investigation is warranted. Like if you ever go in and find, oh no, all of our assumptions are totally correct, then you can stop looking. But more often it's the other, right? Like it doesn't take much looking to find one of those situations and go, hey, we can save a bunch of money here, or we could tear out this thing that no longer even matters and reduce a whole series of risks that we're facing, or we can make this system much more reliable. Those types of things. Like the wins are always there. So it's easy money if you go looking for it, and you should probably do it more often.
Yeah, I was going to call out a couple of pieces. One, to Yuri's point about like our customers don't care, so when we have an outage or when we think we've had an outage, so we should revisit our SLOs. I think another thing to keep an eye on is like what is the operational load of the team, and as that creeps up, like where is your correction point, and to actually really commit to correcting when you hit those. In terms of when do we go looking, personally, my experience is that organizations mostly do this when they have an incident. And I don't know that that's necessarily a terrible time, as long as you actually devote the time to really doing it with your incidents.
Okay, we got another question from the audience. What are some good ways to get reliability buy-in from feature teams, meaning software engineers and such, like in terms of health checks and specifics? How do I get buy-in?
I think sort of like the thing about making it easy for them is also like you want to have it baked in as much as possible, right? Whether that's as part of your platform. You don't want to make every feature team have to go re-implement their own logging or metrics or scale, automatic scaling and things like that, right? They want to go implement their feature. So as much as you can, without putting roadblocks in their way, but as much as you can build systems success much more often.
One thing I like particularly is unification. I like the fact that when you unify tools and systems, you're kind of providing a standardized way internally of doing things. No, I know that a bunch of companies sometimes are moving slowly, and one of the risks that you have with that is that you end up having like two different standards working aside. But generally, it's like that's the thing that's going to grow organically in a company, because some people are going to work one way, some people are going to work another way, and you end up having different standards to kind of pursue with. But there needs to be at some point some work item that needs to be prioritized at some moment in your company life to unify the systems and to make your life better. And what I'm saying by that is that when we're talking about unifying logging, we're also talking about everyone knowing where to look for when there is a problem. You don't have to know, oh, actually that logging is done there, or this one for this application is there. It's like you know exactly where to look for and where to look for the information you need. And we're talking logging, we're talking about other kind of information, centralized documentation about the things and the way your platform is developed that other developers can access. And like even centralized ways that your systems are accessed from the outside. Because if you end up having many different paths that customers can take to reach your platform, you end up having many different ways this can fail. And it's kind of bad to, like, for resiliency purposes and for debugging when something happens, but it's also bad for feature, right? Because if you want to have feature parity across your platform or deploy a new feature, you don't need to do it over one path, but do it over the X path you developed along the way. So at some point, you need to unify that and make it one in some way, like, of course, taking into account that there is sometimes some exceptions, but to simplify your life in terms of keeping your platform alive and keeping like your platform going forward and developing new features and bringing new content to the people using your platform?
I have a couple of tricks that I use just to sell sort of emotionally the idea of monitoring and reliability to feature teams. Trick number one is just to ask them, how do you know if your users are happy? Can you tell? Are people using it? Just ask and see what answer you get, because oftentimes they will work out themselves from that they need some form of reliability checks and monitoring. The other one is that I've never met a software engineer who doesn't like looking at a graph that goes up and to the right. And you can tell them that they can make such a graph, and that's really cool. And sometimes depending on how you're organized, those emotional tips, just making it cool, making it interesting, can get you pretty far.
All right, great. We have one last question. Hopefully we can squeeze it in. And again, thank you to everybody for joining, and thank you to all of this panel. It's been great. For those rewriting legacy application architecture to be cloud native, what do you suggest be in place at the foundational level so that reliability measurements are available and scalable? So trying to do a cloud migration, what should I be doing? Where should I begin?
Being able to tell if it works is really the answer. I mean, do you have monitoring in your existing system? Does that give you a reasonable proxy to whether it works for your customers? And put that in the cloud as part of your early migration, so that as you move pieces over, you can continue to see, does it work? And then do a safe migration, do a shadow launch. So launch on the cloud, but don't have that actually serving your user traffic, and then slowly switch over so that your cloud service is actually serving user traffic. Like, that's sort of but visibility is really the foundation.
Yeah. Before we even get to visibility or like the metrics and logging and other sort of framework things, the other one I would say is like the ability to iterate quickly, like to have a fast feedback loop to where you can try it a little bit and then like figure out, oh, it didn't work this time because of X, and then go fix that thing and then try it again, right? Obviously all in a safe environment, but there's always going to be 100 tiny little roadblocks. So the faster you can like fix one and then confirm that it's fixed and then do the next one. So starting from the ground up with what is like the fastest way that we can get it, try it, and then
Yuri, were you going to add something there, Yuri?
Yeah, just one, I think, tactical thing is if you do have the opportunity, a lot of the managed services the cloud providers create actually do a really good job of integrating with their telemetry stack right out of the box. So if you have the option, if you have the choice, you could use these managed services to get a lot of these metrics and logs and traces done for you without you having the need to really do anything. I realize that's not always an option for people. If you're doing a migration, maybe you are doing something that's more like a lift and shift. But if you have the ability to use these things that are like serverless or managed, where a lot of this telemetry is just done for you, it just makes stuff a lot easier when you're just getting started. And it's a good way to get that fast feedback loop that Drew's talking about without the need to worry about all the infrastructure instrumentation that you might have to do if you're just spinning up a bunch of raw VMs and then trying to orchestrate them and corral them and things like that. Again, with the caveat, that's not an option for everyone, but if it is an option for you, there could be a lot of benefits there, specifically for the purposes of telemetry and observability.
Yeah, and to add to that, I agree with everything that's been said. I think that monitoring is something that you need to have early on, but not only to know if your service is working, but also being able to compare the performance of what you're deploying, right? You're creating something new. You're even if it's the same service that you try to have in the cloud, you want it to have at least the same level of performance. So you want to make sure that you have that data to be able to make sure you're not degrading the quality of what you've been building and providing your customers. So that's something very important to be able to look for. So you need to make sure you have the right metrics. And also remembering that if all your services are always green, maybe there's something you're not looking at.
If you migrate and it's not broken, it's definitely broken.
Yeah, there might be something else missing somewhere.
Perfect note to end it on. Again, thank you so much, everybody, for joining. Look forward to see you at more Dash.